layers of the atmosphere. Go ahead and follow along with your guided notes, and when you need to write something down, make sure you push the pause button. Alright, the Earth is made up of layers, but guess what else is made up of layers? The atmosphere has layers. In this photograph here from space, you can see the different layers of the atmosphere here. Now here is the Earth here. We've got the ocean, clouds, and then this little white line is the troposphere. That's the lowest layer of the atmosphere where all weather happens. Next is the stratosphere, which is this blue area. And then above that, we have our other layers of the atmosphere. Now, our atmosphere actually ends about here. It's really dark because there's not very many molecules. Not many molecules are actually scattering the light, so you can't see the atmosphere here because it's not glowing. But the atmosphere does extend out into space. It is very thin, however. So the most dense layers are going to be at the bottom. This says just like every other layer. Layers of the Earth, the most dense layer is the core because it's in the middle. The most dense layers of the atmosphere are going to be at the bottom. All right, go ahead and write this down. The atmosphere is made up of layers. We have the troposphere, the stratosphere, the mesosphere, thermosphere, and the exosphere. Pause if you need more time to write that down. So in diagrams, we tend to exaggerate our layers of the atmosphere. So here in the diagram, you can see Earth here is a mountain, and then the atmosphere is highly exaggerated. Now you have the same diagram in your notes, but this is showing what's going on at the different layers. So the troposphere here, this line here, the zigzagging line, this is showing us temperature. It says that there at the bottom. The temperatures are all shown in Fahrenheit and in Celsius. So if you can see this, the hottest layer of the atmosphere is actually way up in the thermosphere, which is kind of strange. But it doesn't really feel that warm because of the fact that there's not very many molecules transferring the heat. So any molecule gets hit with the sun's radiation up there, vibrates very quickly, very hard, and it's going to give off a lot of heat radiation. But the fact is there's just not that many air molecules up there because, as we said before, the most dense layers are going to be connected here around the Earth. There are not enough oxygen molecules to breathe in the thermosphere. Like I said, it's really, really thin up there. There's actually not enough air molecules or oxygen molecules to breathe in the stratosphere. And in fact, there's not enough air molecules even to breathe here down at the top, mountain tops in the troposphere, the highest mountains. All right, let's go ahead and write down some important facts about different layers of the atmosphere. The thermosphere is what we're going to start with first. It's written down in your notes. Thermosphere is where auroras occur. So if you've ever seen the northern lights, that's where these are happening. Solar flares come in from the sun. They excite the molecules here, cause the electrons to jump their shells, and then we see a display of light. The next is the mesosphere. Meso means middle. So yes, we have the exosphere on the top. Mesosphere is in the middle. The mesosphere is where we see shooting stars. This is where meteors are going to start burning up in our atmosphere. Most of them get burned up in this layer and gets thicker as we move down to the stratosphere. The most important thing about the stratosphere is that is where the ozone layer is. So the ozone layer exists in a section of the stratosphere. Now the ozone layer is just made up of ozone molecules. Basically, they're not as dense as some of the other layers below, and so ozone molecules will tend to float up here into the stratosphere and form a nice band of ozone molecules. Now the troposphere is the bottom layer of the atmosphere that touches the Earth, that touches you on a daily basis. Even planes will fly here unless you're a fighter pilot. Any commercial airlines will fly in the troposphere. Almost all clouds are created, and this is where all weather happens. So the troposphere is where all weather happens. So the troposphere is where all weather occurs. This includes hurricanes, tornadoes, thunderstorms, cloud formation, winds are happening here. Basically, it's just where things are happening. Now, like we said before, the stratosphere is very important because it holds 90% of all the Earth's ozone. Now, here at the diagram, you can see ozone is important because as the sun's sending out its electromagnetic radiation, it also sends out ultraviolet radiation. Now, most of the ultraviolet radiation from the sun, the harmful UV radiation, is filtered by this ozone layer. If we didn't have this filtering of this UV light, plants would have a hard time surviving on the surface. We would get instant sunburns. Basically, no life would be able to exist on the surface of our planet. It would all have to exist in the oceans under that protective layer of the water. So ozone is an important gas that absorbs UV radiation, that's ultraviolet radiation, from the sun. And this radiation, this is what's going to burn and blister our skin in brief moments. However, ozone is also bad for us as well. So ozone is good because it helps us keep alive and stuff, and allows our skin to stay on our bodies and not to have cancer as much. Anyway, so that's cool. But ozone is actually a poisonous gas to breathe. So while it exists in the stratosphere, it is highly beneficial. But when it is created and is floating around here where we breathe in the troposphere, in the place that things are happening, it's actually very toxic for us to breathe. Ozone interacts with other molecules that your body is made up of, and it basically rips life cells apart. So when you breathe it in, what's happening is it attacks the tissue in your lungs, the cells that your lungs are made up of, and it starts to kind of destroy them and damage them. So ozone, if you were to just breathe ozone in, it would burn your throat. Now, on some really bad pollution days, you can feel this when you're breathing in, especially when ozone is high, that it starts to burn your throat and it burns your lungs as you're breathing and inhaling. So ozone molecules are highly reactive oxidizing agents that tend to stick to large molecules lining our respiratory tracts. That's already written for you. Part you need to write down is ozone chemically reacts with the cells in our airways, damaging cells. This can lead to asthma attacks, inflammation, so inflammation is that burning you're feeling, irritation, burning, and basically just make it hard to breathe. And because of this, it is actually considered an air pollutant when it exists in the troposphere. So it's beneficial to us in the stratosphere, but it's a pollutant because it harms us when it exists in the troposphere. So the ozone hole. In case you didn't know, there is an ozone hole that permanently sits over Antarctica. A few reasons for this is because of the special clouds that allow the reactions to take place, and as well as the really, really cold, frigid temperatures that exist there. Now, there's also an ozone hole that happens seasonally over the North Pole as well, but the Antarctic one is just larger and it stays there pretty much permanently year-round. So what we discovered a while ago was that CFCs, these chlorofluorocarbons that we talked about in our greenhouse section, they actually react with the ozone molecule, the O3 molecule, and they create new chemical bonds and different molecules. And what happens is this tends to remove the ozone from the ozone layer, which leaves those gaps or holes in the ozone. So when we have this, basically we have no protection from that UV radiation. So Antarctica and the animals living in that area are getting hit with a full force of UV radiation, and it's very bad for them, and it's bad for us on the planet entirely, because that means that UV radiation is getting in and it's bouncing around and just causing higher cancer rates around the world. Now here, this image here, this is 1979, so the year I was born. This is showing the ozone hole. Where it's mostly blue shows a hole, and then it's thicker in regions that are green and orange. So you can see it here concentrated over Antarctica. If we move over to 1980 here, you can see that the ozone has gotten larger, got a little bit less on 81. In 2000, the ozone hole was very large. Now, it depends on the season. It tends to open up and close up quite a bit depending on how cold it is that season. 2002, see it here in 2006, 2012, 2013, and then here it is in 2014. So we worked hard to stop using CFCs, but unfortunately they are still floating around in the atmosphere. And we have a video to watch that kind of explains how that works and why that created an ozone hole. All right, so you're going to go ahead and watch this in your next video. I'm not going to play it here because then you have to hear the speakers on my video here, and it's not going to be good. So after you watch this video and you've taken all those notes, go ahead and play this next video and watch it with your headset.